Okey, Assalamualaikum dan selamat pagi semua. Okey, so pada pagi ni kita akan membincangkan topik 7 iaitu Geometrical Optics ya. Okey, topik ni agak panjang dan penuh dengan konsep ya. Jadi kena alert dengan setiap subtopik dia. Okey? Sebab soalan akan keluar based kepada setiap subtopik yang ada dalam topik ni. Alright? Okey. So sebelum tu kita tengok dulu dekat dia punya learning outcome ya bagi topik ni. Okay, first kita ada 7.1. Okay, reflection at a spherical surface. Okay, so state radius of curvature R equal to 2F for spherical mirror. Okay, sketch ray diagram with a minimum of 2 rays to determine the characteristic of the image formed by spherical mirrors. And then use mirror equation. Okay, 1 over F equal to 1 over U plus 1 over V for real object only. Okay. So kat sini bila kita nak gunakan mirror equation ni, kita kena tahu dia punya sign convention ya. Okay. So sign convention for focal length F. So positive F for the concave mirror. Okay, negative F for the convex mirror. And then define and use magnification. Okay, ini adalah formula bagi magnification. M equal to HI over H0 dan juga M equal to negative V over U. Okay, so ini adalah formula bagi magnification. Okay, pembesaran. So ini adalah mirror equation ya. 1 over F equal to 1 over U plus 1 over V. So bila kita nak guna formula ni, kita kena ganti dia punya sign convention pada F, pada U dan juga pada V. Sama juga yang ni ya. Okay, untuk V dengan U ni, kita kena ganti sign convention dia. Okay, dia ada rule dia lah. Okay, nanti kita akan tengok detail. Alright? Okay. Now, okay, subtopic 7.2. Refraction at a spherical surface. Okay, so reflection ni tadi dia pantulan. Okay, reflection pantulan. Refraction pembiasan. Okay, so you kena alert dengan these two terms ya. Okay, refraction pembiasan. Okay. So kat sini kita ada okay, use N1 over U plus N2 over V equal to N2 minus N1 over R. Okay, for spherical surface. So ini adalah formula bagi refraction on spherical surface. Ya, ni konsep something new to you lah. Okay, ni konsep yang something new. Okay, refraction on spherical surface. So, ni pun sama. Bila kita nak substitute, dia ada sign convention dia. Okay. So, sign convention for radius of curvature R. Okay, positive R for convex surface. Okay, negative R for concave surface. Kalau convex surface, R dia positif. Kalau concave surface, R dia negatif. You kena put the negative sign. Okay, in the equation. Alright. Now, tengok subtopic 7.3. Thin lenses. Okay, kanta nipis ya. Okay. So, A, sketch ray diagram with a minimum 2 rays to determine the characteristic of the image formed by concave and convex lenses. B, use thin lens equation. 1 over F equal to 1 over U plus 1 over V for real object only. Okay. So, ini adalah lens equation. Okay, 1 over F equal to 1 over U plus 1 over V for real object only. Okay, sign convention for focal length F. Okay, positive F for convex lens, negative F for concave lens. Okay, and then ini determine the focal length of a convex lens. Kita akan buat eksperimen 5 lah, geometrical optics. Okay, kemudian kita akan belajar state and use lens maker equation. Okay, lens maker equation ya. So 1 over F equal to N material divided by N medium minus 1. Okay, darab 1 over R1 minus 1 over R2. Kalau N dia adalah udara, so dia sama dengan 1 lah. Kita gantikan nilai 1 lah. Okay, refractive index untuk udara adalah 1. Okay, depend on the material lah this one. Okay, so ini adalah lens maker equation. So pun ni nanti kita akan go detail. So, you kena tahulah bila nak guna this equation, macam mana nak guna. And what is the sign convention yang you kena tahu. Ada juga ya, this one ya. Alright. Okay, kemudian Define and use magnification. M equal to HI over H0 equal to negative V over U. So, ini adalah magnification bagi thin lenses ya. Alright. Okay, boleh ya? Alright. So, ini adalah learning outcome yang kita yang awak kena tahulah. Okay, by the end of the by the end of the lecture ya. So, you kena tahulah. You kena kuasai all of this learning outcome. Okay? Alright. Okay, now kita tengok kepada mind map sikit untuk topik ni. Okay ya, ni yang kita tengok tadi. So, geometrical optics. Okay, kita ada 3 bahagian. 7.1 reflection at spherical surface. 7.2 refraction at spherical surface. Dan 7.3 thin lenses. Okay, 7.1 reflection at spherical surface ada 2. Okay, law of refraction dan juga spherical mirror. Okay, under spherical mirror, so kita ada concave mirror, convex mirror. Melukis ray diagram ya untuk mendapatkan image yang terbentuk. Dan juga mirror equation. Okay, mirror equation ni 2 sama ada you nak guna 1 over F. Okay, 1 over F equal to 1 over U plus 1 over V. Atau you nak guna 1 over U equal to 1 over V equal to 1 over U plus 1 over V equal to 2 over R. Either one lah. Okay, salah satu. Okay, alright. Okay, kemudian under 7.2 refraction at spherical surface. Okay ya, so refraction ni divide 2 ya. Satu refraction at spherical surface, satu lagi adalah thin lenses. Okay, kalau dekat spherical surface ni lah. Okay, yang tadi kan kita ada persamaan ya. Equation dekat refraction at spherical surface tu. Okay. Dan kalau untuk refraction, okay, thin lenses. So, sama juga kita ada melukis ray diagram to look the image form ya by the thin lenses. Kita ada convex thin lenses, concave thin lenses. Dan juga equation ya, thin lenses equation. This one ni. Okay. Boleh ya? So, ini adalah mind map lah. Okay, simple mind map bagi topik ini. Okay. Alright, sebelum kita go detail mengenai konsep, kita tengok sikit lah dulu kepada definition yang ada lah bagi topik ni ya. At least kamu tahulah sebelum kita go detail kepada konsep untuk setiap subtopik. Okay. Alright. So, definition and concept geometrical optic. So, benda ni penting untuk kamu hafal semuanya sebab nanti dia akan keluar dekat UPS 3. Okay, UPS 3 ya. Okay. So, at least kena hafal dan tahulah all the terms. Okay. Alright. Pertama. Okay, reflection of light is defined as the return of all part of a beam of light when it encounters the boundary between two media. Okay, ini adalah reflection. Reflection pantulan ya, pantulan. Okay. Okay, law of refraction state that okay, the incident ray, the refracted ray and the normal all lie in the same plane. Lepas tu the angle of incident I equals to the angle of reflection R. Okay, so law of reflection ada 2 ya. Okay, this is the first one, this is the second one. Right. Okay, kemudian tengok pada spherical mirror is defined as the reflecting surface that is a part of the sphere. Okay, itu adalah spherical mirror. Okay, so there are 2 types of spherical mirror. So, it is a convex curving upwards and also concave curving inwards ya. Ingat, kalau convex dia curving upwards, kalau concave curving inwards. Okay, mirror. Okay. So, ini adalah terms-terms yang ada pada spherical mirror yang you kena tahu. Okay, pertama kita ada center of curvature. The symbol is C. Is defined as the center of the sphere of which a curved mirror forms a part. Okay, then we have the radius of curvature. The symbol is R, small r. Is defined as the radius of the sphere of which curved mirror forms a part. And then kita ada pole or vertex. Okay, is defined as the point of the center of the mirror. Okay. Okay, then kita ada principal axis. Okay, is defined as the straight line through the center of curvature C and pole P of the mirror. Okay, kemudian kita ada focal point or focus point. Okay, dia dua benda sama ya. Focal point adapun focus point, the symbol is F. Okay, for concave mirror, is defined as the point where the incident parallel rays converge after reflection on the mirror. Okay, so inilah focal point ataupun focus point F. Okay, dan kita tengok kepada okay, focal point ataupun focus point F. Okay, ini tadi untuk concave mirror. Okay. Okay, once again ya. Okay, focal point or focus point F for a concave mirror is defined as the point where the incident parallel rays converge. Okay, ingat ya. Converge after reflection on the mirror. Kalau bagi focal point ataupun focus point F for the convex mirror, so it's defined as the point where the incident parallel rays seem to diverge from a point behind the mirror after the reflection. So diverge So tadi kalau concave mirror dia converge after reflection. Kalau convex mirror seems to diverge from a point behind the mirror after the reflection. Okay, then kita ada focal length F kecil. Okay, it's defined as the distance between the focal point F and pole of the mirror. Okay, pole P of the spherical mirror ya. So itu adalah focal length. Okay, small f. Kalau capital F, focal point ataupun focus point. Okay, F kecil focal length ya. Okay, then the parallel rays is defined as the rays that are near to and almost parallel to the principal axis. Okay. Alright. Okay, sekarang tengok pada ray diagram. Okay, ray diagrams is defined as a simple graphical method to indicate the position of the object and image in a system of mirrors or lenses. So, ini adalah ray diagram lah ya. Okay. Simple graphical method. Okay. To indicate the position of the object and image in a system of mirrors or lenses. So, kita ada virtual image. Okay. Virtual is seen to form by light coming from the image, but light does not actually pass through the image. Okay. Okay, then kita ada refraction is defined as the changing of direction of light ray and its speed of propagation as it passes from one medium into another. So, itu adalah refraction. Okay, pembiasan. Okay, so kita ada law of refraction, Snell's law. Okay, ataupun law of refraction state that pertama, the incident ray, the refracted ray and normal all lie in the same plane. Okay, kedua, for two given media, okay, Snell's law state that sin I over sin R equal to N2 over N1 equal to constant. So when we rearrange the equation, so it can be like this lah. N1 sin I equal to N2 sin R. Okay. Alright. Okay, then kita ada refractive index. Okay, refractive index. So refractive index is defined as a constant ratio sin I over sin R for the two given media. So, relationship between a refractive index and the wavelength of the light. Okay. Ni kena tahu juga konsepnya sikit. So, as the light travels from one medium to another, so its wavelength lambda changes. Okay, berubah ya. Lambda berubah, but its frequency F remain constant. Okay, ni bila cahaya travels ya from one medium into another. So, the wavelength changes because of different material. Okay. So, the frequency remain constant because the number of wave cycles arriving per unit time must equal to the number leaving per unit time, so that the boundary surface cannot create or destroy the wave. Okay, so ni relationship yang kita boleh gunakan lah. N1 lambda 1 equal to N2 lambda 2. Okay. Okay, sekarang tengok untuk thin lenses pula. Okay, thin lenses is defined as a transparent material with two spherical refractive surface whose thickness is thin compared to the radius of curvature of the two refracting surface. So thin lenses is defined as the center of the sphere of which the surface of the lens is apart. Okay, terms of thin lenses. Okay, center of curvature, point C1 and C2 is defined as the center of the sphere of which the surface of the lens is apart. Okay. Okay, dan kita ni center of curvature dia dua ya untuk lens, C1 dengan C2. Kalau untuk mirror ada satu je ya, tapi kalau untuk lens dia ada dua ya, C1 dan C2. Okay, ni center of curvature. Dan kita ada radius of curvature. So, simbol pun sama R1 dan R2 lah. Okay, it's defined as the radius of the sphere of which the surface of the lens is apart. Okay. Okay, kemudian kita ada optical center. Okay, point O is defined as a point at which any rays entering the lens pass through without deviation. Okay. So, ini adalah optical center ya. Simbol ni adalah O. Okay, dan kita ada principal optical axis is defined as the line joining the two center of the two center of the curvature of the lens. So principal ataupun optical axis. Okay, then focal point or focus point for the concave lens. Okay, focal point or focus point for the concave lens. Okay, concave lens ni kita panggil sebagai diverging lens ya. Okay, concave lens ataupun diverging lens is defined as a point on the principal axis where rays which are parallel to the principal axis seem to diverge, okay, from after passing through the lens. So its focus is virtual. Okay. Okay, ni pula focal point or focus point for convex converging lens. Okay, for convex or converging lens. So its method is defined as the point on the principal axis where rays which are parallel and close to the principal axis converge after passing through the lens. So its focus is real principal. Okay, alright. Okay, kemudian kita ada for concave ataupun diverging lens is defined as a point on the principal axis which rays where rays which are parallel to the principal axis seems to diverge from after passing through the lens. So its focus is virtual. Okay, so focal length is defined as the distance between the focus F and the optical center O of the lens. Okay. Okay, kemudian kita ada linear magnification. Okay, ataupun linear lateral magnification of the spherical mirror. M is defined as the ratio between image height and object height. Okay, H0. Okay. So, M equal to H I over H0 equal to negative V over U. Okay, lepas tu kita ada concept of combination of lens. Okay. So, the image of formed by the first lens is treated as the object for the second lens. And the final image is the image formed by second lens. So, the position of the final image in a two-lens system can be determined by applying the thin lens formula to each lens separately. Okay. So nanti kita boleh carilah. Okay, position of the final image tu menggunakan this thing juga. Okay. Okay, boleh ya. Alright. So ini definition yang ada lah dalam subtopik ni. At least awak kena tahu ya. Okay. Okay, sekarang kita tengok kepada beberapa equation lah yang ada dalam topik ni. Okay, the detail kita akan tengok lepas ni. Okay, so pertama tadi, check tadi, spherical mirror equation. 1 over F equal to 1 over U plus 1 over V. Sama ada you guna, the first one boleh guna depan ni kan. Okay. Ataupun, you boleh guna ni. 1 over U plus 1 over V equal to 2 over R. So, U adalah object distance from optical center. V adalah image distance from optical center. F adalah focal length. Okay. F adalah focal length. Dan R adalah radius of curvature. Okay. So, radius of curvature ni hanya ada dekat dalam mirror saja. Maksudnya persamaan yang bawah ni. R sama dengan 2F ni, kita hanya boleh guna dalam mirror saja. Okay. Dalam lens tak ada ya. Ni dalam mirror saja yang ada. Okay. Alright. Okay, pertama. Okay, kedua. Relationship between focal length F and radius of curvature R. So, kita ada R sama dengan 2F. Ataupun F sama dengan R over 2. So, F will be the focal length. R will be radius of curvature. Okay, R sama dengan 2F. So, persamaan ni boleh digunakan dalam untuk cermin sahaja. Okay, concave mirror, convex mirror. Okay, tempat lain tak boleh especially for the lens. Okay, kemudian kita ada linear magnification. So, M equal to HI over H0 equal to negative V over U. Okay. So, U adalah object distance from the pole. V adalah image distance from the pole. HI adalah image of the height. HI adalah height of the image. Dan H0 adalah height of the object. Okay. Right. Okay, dan kita ada Snell's law. So, N1 sin I equal to N2 sin R. Ataupun sin I divided by sin R. Sama dengan N2 over N1 sama dengan constant. Okay. So, N1 refractive index of medium 1. Medium containing the incident ray. Okay. N2 refractive index of medium 2. Medium containing the refracted ray. Okay. Okay, I adalah angle of incident. Dan R adalah angle of refraction. Okay. Alright. Dan kita ada the refractive index N. Okay. Okay, consider the light rays travel from medium 1 into medium 2. The refractive index can be denoted by 1 and 2. Okay, ni penulisan dia lah. 1 and 2. Maksudnya, light rays travels from medium 1 into medium 2. Okay. Alright. Ataupun ni formula lain lah yang kita boleh gunakan. And 1 and 2 sama dengan velocity of the height in medium 1. So, V1. Velocity of the light in medium 2. V2. Okay. Okay. Kemudian, so kita ada absolute refractive index. N for the incident ray travels from vacuum of air into the medium. So, N equal to C over V. N adalah refractive index. C adalah velocity of the light in vacuum. Dan V adalah velocity of the light in medium. Okay, in medium. Okay. Okay, ni pun lagi satu formula untuk mencari real depth dengan apparent depth. Okay, N sama dengan N1 over N2 lah. So, N1 real depth, N2 apparent depth. Okay, so next, okay, equation for absolute refractive index N in terms of the depth. So, boleh guna N1 lambda 1 sama dengan M2 lambda 2. Okay, refractive index is usually proportional to the wavelength, to the wavelength. Ataupun boleh guna N equal to lambda naught divided by lambda. If medium 1 is a vacuum or air, then N1 equal to 1. So, A0 equal to wavelength of the light in vacuum. Lambda refer to wavelength of the light in medium. Okay. Okay, kemudian ini pula, okay, relationship between refractive index and the wavelength of the light. Ni jadi. Okay, N1 over U sama dengan N2 over V sama dengan N2 minus N1 over R. Okay. So, tengok terms dia sikit. N1 refractive index of medium 1, medium containing incident ray. N2 refractive index of medium 2, medium containing the refracted ray. Okay, ya. Okay, U, object distance from the pole. V, image distance from the pole. R, radius of curvature. Okay, next, equation of spherical refracting surface. Okay, ni kalau special case lah. Okay. So, R sama dengan infinity, hampir infinity. So, bila kita dah modify the persamaan, so N1 over U plus N2 over V sama dengan 0. So, same as above, if the refractive index subject is flat, so R sama dengan infinity. Okay. Alright. So, ini pula adalah the equation formula of linear magnification for refraction by spherical surface. Okay, ni formula dia. M equal to Hi over H0 equal to N1V, N2V. Okay. Okay, M equal to, okay, once again ya. M equal to H1 over H0 equal to negative N1V, N1V, N2U ya. So, ataupun N equal to lambda naught divided by lambda. So, N1 refractive index of medium 1, medium containing incident ray. N2 medium refractive index of medium 2, medium containing refracted ray. U, object distance from the pole. V, image distance from the pole. Hi, height of image. H0, height of object. Dan M adalah magnification. Okay. Okay, next kita ada lens maker equation. So, ni formula dia. Okay, pertama 1 over F equal to in bracket N material over N medium minus 1. Okay, in bracket 1 over R1 minus 1 over R2. Okay, yang kedua bila dah modify sikit jadi 1 over F equal to N2, N1 minus 1. 1 over R1 minus 1 over R2. So, N1 refractive index of medium 1. N2 refractive index of lens material. R1 radius curvature of first refracting surface. Okay. Oh, yang ni sepatutnya R2. Tinggal. Okay, R2 radius of curvature for second refractive surface. Dan F will be the focal length. Okay. So, ini lens maker equation yang telah dimodify. Okay, if the medium is air, so N1 sama dengan NA sama dengan 1. So, persamaan jadi macam ni lah. Okay, 1 over F equal to N minus 1 in bracket 1 over R1 minus 1 over R2. So, if the medium is air, so N1 sama dengan NA sama dengan 1. Okay, kemudian tengok pada Thin's lens formula. Okay, 1 over U plus 1 over V equal to 1 over F. Okay, U, object distance from optical center. V, image distance from optical center. Dan F adalah focal length. Okay, ni kalau cari overall magnification of the two lens system. So, MF sama dengan M1 darab dengan M2. So, MF overall magnification. M1 magnification due to the first lens. M2 magnification due to second lens. Okay. Alright, so inilah di antara definisi, konsep dan juga formula yang ada dalam topik ni. Dia memang agak banyak ya sikit. Dan you kena tahu detail semuanya. Okay, alright. Okay. Okay ya. So next kita tengok kepada konsep-konsep penting yang ada untuk setiap subtopik lah. Okay. Pertama untuk mirror. So kita start dengan concave mirror. Okay, nampak ya. So ini kita punya concave mirror lah. Nampak ya, concave. Concave ni dia cekung kan. Okay, cermin cekung. So bila cermin cekung, ini front bahagian depan, ini back ya bahagian belakang. So this is the front, this is the back. Okay, ni adalah center of curvature. So ini pole of the mirror. Okay, so R ni adalah radius of curvature. Okay, radius of curvature. Okay, kemudian macam saya cakap tadi, kita ada spherical mirror equation. Okay, 1 over F equal to 1 over U plus 1 over V. Okay, ataupun, okay, ni ya, the first one we have this. Okay. Okay, ataupun the second one we have this. 1 over U plus 1 over V equal to 2 over R lah. Okay. So, dua persamaan ni kita boleh guna lah. Kalau saya cari focal length, mungkin boleh guna yang ni. Kalau cari radius of curvature, guna yang ini. Okay. Alright. Kemudian kita ada R.